Okay, I promise now we're going to do some testing. And so what I'd like to do, let's just start here with the request. And we're going to keep this open, but move it down a little bit because I really care that this happened. Normally I would be full screen, twice this size. But now let's do a test. And I do want to do this this way. Use super. This is not strictly needed, but I might be pulling in some additional libraries, and I don't want to pollute the space out there. So oftentimes I'll wrap my tests like this, unless it's like just really, really simple. So we're going to test fn test request parser. And I don't have any hard and fast rules. And actually, I'm going to let I'm going to let Copilot complete the first things because I don't know. It's fine. Like that's going to be what I'm doing. Man, it's really nice having that AI assistant because like this is it just saved me a lot of time to write the first 3 tests and get everything going, and now I can start playing with it and see how I can break it. And what I was saying is I don't have any hard and fast rules for like one assert, one test per function. I care more that it's testing. Like I'm okay with having 320 of these in a single test. I might do this. Oops. Here ser success, or maybe good, happy path. That's normally what I'll do. And then say, and what's nice is Copilot's going to know what I'm doing. Test request parser, bad verbs. And that's not a bad verb. That's a bad verb. And this I don't think will pass. So bad verbs is going to pass. And I don't want that to pass. This should be an error. And I'm curious, let me see. I think I can do returned request is, and I think I can do this to give me some better information. Returned request is okay and unidentified. That's not good. We want them to be one of 3 things. I'm going to actually say one of 2 things. I want to take out that unidentified. It should be the responsibility of this to produce a valid request, and it just must be. So let's get this going. And so the first part, this is an okay way of doing it. We're splitting it by white space. That's fine. Like I said, I don't know if this is a proper parser, but I'm going to go with this. So if next returns an option none, we want to say okay or else, and turn this into a no method found. Actually, let's only fix one thing at a time here. We need to return, or we need to bail so anyhow bail will return this error message when it fails. We're not compiling because it's trying to return one of these guys. Okay, I need to reduce the font size a little bit so I get more real estate. Hopefully you can still see it. Here, let me save so I get it to compile again. Consider using request parse, which returns something. That's interesting. You're attempting to build a new request. Consider using request parse, which returns. I don't know what it's trying to say there. Hold on. Just lost track of where it is, where my error message is. Hold on. There we go. So I can scroll up, find that white space. Wow, a lot of things missing. Oh. Request error handler. Oh. So this sort of means that we need to. I don't like this. I don't want to multiplex the good and the bad inside of every request. I want sort of the good and bad to be handled by an error and a completely good request. Here's why. Okay, so we're getting into a little bit of philosophy now. Not engineering philosophy. A request. I want a request to be a valid request. If it's not, every place that I try to do something with a request, I have to first check to see, am I going to go down the good path or the bad path? And I would rather have my processing figure out that it is a good path to go down and then find handlers that are accepting the good path. Otherwise, sort of the handlers and even the checking of that need to say, okay, which way are we going? And I understand the idea behind this because this sort of filtering is not done at the handler level, but it puts this into a state that is not a single dimensional state. So request in the mode that it was in before would have a state that is good and a state that is bad. And for states that is good, it has a list of states that could be good. And I want the enum to be a singular dimensional container that has only good things in it. So I'm going to go off a little bit of refactoring here because the handlers here, I think I can do this by, I'm going to change this hash map to be type handler map is going to be, it's currently that, but I want this to be an option. And I don't really love this yet either. Okay, so the register handler, this is going to put in some of that. Insert, oh. And instead of multiplexing good and bad in here, the handlers that are finding none in there, register handler. Oh, I don't want a register handler. I want to and I think this can actually panic, can it? Cannot mutate immutable. Oh, right. Because insert, if it already exists, what happens? Okay, if the did have the present, the values updated and the old values returned. So, you know, like these can overwrite things. Is that okay? We're not communicating that we did overwrite something. So, like, really, these need to indicate that overwrite value to the caller, but out of scope for what we're doing here. So our handle connection here, the handle connection is this handler map. Good. Should have done that before. And we're matching on the request here. And if the request is not identified, so sorry, read and parse request. So we already error out here. We're never actually returning the error value. Ah, yeah. That's okay. Let's do that. Yeah. I'm changing some of the logic of get hash request. That's a request. That's what we need to pass into there. If we get it, if we don't get it, now, and this might be the better way to handle it. In the none case, find the none handler in handlers. So if let 404 handler equal none, then we call it otherwise. We apparently do have our default 404 handler. Handler is an option box. No, if let some 404 handler equal that. There we go. This is closer. Let me finish this off and see if we can get this to run. So put, we don't know what that verb is. So that's not a happy path right now. Okay, we are all passing, and we're even passing erroring out on this. So let's see what I just did. And we have more tests. We have two more tests. We have twice as many tests as we had before. Fantastic. So my request certainly kind of changed the design to say, okay, requests are going to be get, post, put, and delete. Currently, we're only handling these two, and this is great because as we go on, when we add another verb, since we're using match statements to exhaustively match the request, we'll have to implement that correctly everywhere we're doing this. This still needs to be fixed because we don't want default things. The request has to match perfectly for what resource we're looking for. We're not going to make assumptions for what the end browser thought it should get. We just don't do that. And if so, parse can fail, but it's not really failing yet. Oh, it is failing here for this case. So since we don't have an invalid state here, I changed the handler map to be able to handle valid requests through if the key is a sum of some value, and in order to set a singular error handler, which I think you could only set a singular error handler with the other one before. To set a singular error handler, the error handler is going to be the none key of the handler map. I don't like that. I'd rather have a struct that looks like this, like the valid is going to look like that, and and a singular error handler like that. And actually, maybe we have to have an error handler. That'd actually be even better. So I want to close this down and perhaps try to refactor it to do this. But that's, like I said, that's we're better here. I think this will make it even betterer. So in doing this, we had to change how we register stuff, just to be able to say, okay, these are going to be valid ones, these are going to be invalid ones. And then in the parsing of this, I think this just goes away. I don't know why this is a hashed request. I don't know what a hash request is. Let me just delete that. Put in request. We have enough tests that I feel like we're able to use to move value. I don't think I can do that. It's not going to work right. Yeah. So a lot of this is because of, man. Okay, I kind of see why, but let me just clone this here, and I think that'll fix this. We can work on that. Anywhere where I can delete code, I see that as a win. So here's how we just do it. We say, okay, find a handler that matches the request, and the request must be valid here. So we're finding a valid handler in here. And if we find one, we call the handler and we get a response, which is going to be a result because this can fail. I'm going to take out this to-do statement because I think we found a better way to do it. So we try to get the 404 handler. If we don't have that, then we use a default one. And but this statement should be unnecessary. Yeah, that's good. We did in the request put in a way to fail, invalid verbs, and have two tests, one that tests the happy path, one that tests the not happy path. Should be checking for this one, the path. We want the path to be valid, and perhaps this to be valid in some way. And but let's close this down. This has been a long one, but I think important. There's some major refactoring to, almost as a result of trying to do testing and realizing that the implementation path was not ideal for testing, and you find the common thing that makes both testing and implementation work the way you want it to, and you realize that implementation is just better overall. That's one of the main reasons why you do testing, is to expose a path through the code that you may not have considered before. But once you consider that and make an implementation that allows for that, everything is better. I find often that we make compromises in testing because the code wasn't written well for testing. So the testing code does hacks and other things to make testing work. And what it really identifies is that the implementation wasn't right. It wasn't extendable, whatever, to be able to both do an implementation and to do a test. But we compromise our tests then instead of fixing our implementation. Anyway, getting into my TED talk on how to do testing, important stuff, I think. But let's close this out and move on.